The next part is the post-processing of the results. From Workbench, double click on the results icon, cell number A5, or in the case when we are solving the CFX case in the standard mode, you can from the CFX solver click on this launch CFD Post, or you can also launch the CFD Post from the CFX launcher, and after that you can load the results file which has extension of the .res. In either way, you will get the CFD Post file, and if you are looking at the picture here, on the symmetry plane I have the mesh, and on the arrow file surface, because in the CFX it will extrude the mesh by the one cell, so it means that now we have the 3D arrow file. This is by necessity in the solving in the CFX solver. So now we have the 3D case, and we have the one cell thick mesh on the arrow file surface, which you can show by clicking on the show mesh lines when you double click on the arrow files, and from render and then go to show mesh lines. You can also change the color of the mesh lines and also change the color of the surface of the arrow file. So if you want to display the mesh on the symmetry plane, which is quite possible, so you can go again to the render and click on show mesh lines, and you can change the color of your choice. You can also click on show faces to uncheck the box so that you only show the mesh lines on the symmetry plane, and after that you can click on the create contours and choose the arrow file surface and the local and click on apply. This will display the static pressure on the arrow file surface and the mesh on the symmetry plane. You can also display the vector plots on the symmetry plane. Symmetry number 2, and you can change the size of the symbols to the point, let's say 0.8, and apply. You can hide the mesh on the symmetry plane, and also you can reduce size of the vectors to the point 0.4. So you can see that we have the flow is coming from the some angle which is 10 degrees of the angle of attack, which is quite visible here. Like here. You can also display the contour plots on the symmetry plane, and before that hide the vector plots and choose the local and choose symmetry number 2 and apply. Again, you can see that we have the stagnation zone on the arrow file surface, which clearly shows that we have the very high pressure region at the suction side, which is below the leading edge. You can change the plot to the velocity as well. You can change the plot to some turbulent quantities. You can also plot the y plus to get the idea that how the y plus varying on the symmetry plane. So its maximum value is 27.35 and minimum value is 0. And to display, you have to display on some wall, and before that hide the contour 1. So maximum value is on the top side where we have the maximum velocity, and the minimum value is the point where we have the stagnation zone where the velocity is minimum, and therefore we have the minimum value of the y plus. Also, any region where we have the low velocity, you will see that we will have the low value of the y plus. You can also display the vector plots and see that where the velocity is reducing and show the value of the y plus.